Hello and welcome to our discussion about how to complete conversion problems using conversion factors. Today we're going to introduce what a conversion factor is, talk about a definition of it and some different ways that we can identify them, and then go through a planning process for how to tackle conversion problems that are word problems. So keep in mind that all of this is just like converting between, say, inches and feet. Since we know that there are 12 inches in 1 foot, we will be able to use that information to get from feet to inches or inches to feet if that is something we would want to do. So first of all, notice the part boxed there is a use of conversion factors, but not a true definition. We'll get to that in a moment. But if a conversion factor is meant to allow us to convert a value from one unit to another, we should be able to use that to decide if any of the examples below are truly conversion factors or not. So when we look at the first one, it says that we are supposed to rewrite the factors as a fraction or a ratio, and if it's already a fraction, show a different way it can be written. If it's not a conversion factor, we're going to put an X in the box. So the first one says 12 miles. There's no relationship there to another unit. Therefore, we can't use it to get from one unit to another. It's not a conversion factor. Now the 6.23 grams per milliliter relates mass and volume. There's a fixed ratio here. So this one could be used as a conversion factor. If I knew what substance that was and I wanted to know the mass of a given volume, I could use this relationship to do that. Now 75 miles per hour, I could use that to convert from the miles driven to the time it would take. And I could use that in either direction. That's why I flipped it upside down. The relationship is still there no matter which way I write it. So in all of the ones I wrote as fractions, they could be in some context used to convert from one unit to another. And so they can be used as this fraction and could be flipped upside down as well. The last one, again, 30 pounds, does not indicate any kind of relationship from one unit to another. Therefore, it could not be used to convert. So now we're going to define what it is. Now the trick about this definition, this relationship between two units that are equal in quantity, they may not be the same numerical value. For example, let's say that this line I'm about to draw was 1 foot. The length of that line is also 12 inches. The length of the line is the same no matter what unit I use to measure it, but the value on the unit will differ because the units are different sizes. You're going to see things like per, equals. Sometimes a colon is used between them or a division bar. Those are symbols that help you know that you may be looking at a conversion factor, but there are still some things that need to be present. So notice that each part of a conversion factor has to include a unit and a value, and they need to be real relationships. So non-examples, say 13 inches to a foot, that's not true. Counting numbers don't imply any relationship. And even taking a single value with a unit of measurement won't allow you to get from one unit to another. What might that 64 be equal to? What's the relationship? We don't know. So those are some non-examples of conversion factors. So let's say we wanted to tackle a problem that asks us to convert. We're going to use our analyze the prompt strategy with a specific part about the boxing to help us decide. Now, over the years, I've kind of changed my mind on the way that we do this. I like boxing and starring the desired unit because then there's one star that we're looking for. That's the emphasis that we're trying to find. Any other data we can just box. So please follow along and mark what you see in the bold text. So I've marked the starting value. I've determined that we want to know how many minutes. I've starred that. And then notice the two other things I boxed are conversion factors because they meet that criteria of having two units related to each other. Now I'm going to make a plan. I'm going to analyze the problem to decide what I want to solve for. So it says A, identify the unit we begin with. That would be the miles. Then it says, what unit do I want to finish with? Well, we said that's minutes. Now I need to make a plan to see, using the given conversion factors, how can I get to where I need to go? Well, if I'm in miles, I need to find a conversion factor that has miles in it. We see that in the last one, the 1609 meters in 1 mile. So that means I'm going to be able to convert from miles to meters, which gets me closer to my minutes. Now I have to see, is there something that relates meters to time? Now I'm looking for minutes, and I don't see it, but I do see meters in seconds. So from meters, I can convert to a factor of time in seconds. Now there's no more conversion factors in the problem, but the conversion factor from seconds to minutes is kind of well known. So we're going to use 60 seconds equals 1 minute as our last conversion factor. So when we make a plan like this, the benefit is that the number of arrows will equal the number of fraction conversion factors that we're going to use. So we're going to need 3 conversion factors to solve this problem. So let's tackle it. We're going to start with our first value. Then we need to choose how to set up our conversion factor to meters so I can cancel the unit of miles and get to meters. I'm going to take advantage of the fact that when you divide something by itself, it equals 1, which effectively cancels it out. So I'm going to put the miles part on the bottom. So So miles on top, miles on bottom cancels out. Now I'm in meters. Now I need to use the 3 times 10 to the 8th meters per second, and I am going to put the meters on the bottom again to cancel out meters. Lastly, I chose to put the 1 minute on top because that's what I want, and the 60 seconds on the bottom of the conversion factor so that I can cancel the seconds. So all of this is letting the units drive our decisions. I'm going to put the unit I want to cancel opposite where it is right now. If you do the math in your calculator, you should arrive at 0.0215 minutes. To be honest, that is not the time it takes light from the sun to reach Earth. It's longer than that. My starting value is a little bit off. But mathematically, from the problem set numbers we have, that's what you should get. If you don't get that, it's probably a calculator entry issue, and you can come see me for help with that. Now, last problem I would like to do together has a unique situation where the given value has 2 units. So we have to be a little bit more careful on how we set this up. So you'll notice that in my initial part, I said I'm starting in miles per hour and I want to finish in meters per minute. We can still use the 1609 meters per 1 mile in the first conversion. But because I'm dealing with the top, the bottom is still in hours. I can't change them both at the same time. But once I do that conversion step, then I can convert from hours to minutes. So remember, the difference is now I have a unit on the bottom. In the last problem, I did not. So that's going to affect my conversion factor when I get there. So first, I want to cancel miles and get to meters. I could do the minutes first and do the other part second. It really doesn't matter. I just need to do both at some point in the problem. So right now I'm in meters per hour. I got to do one more conversion to get to meters per minute. Well, there are 60 minutes in 1 hour, and the minutes has to be on the bottom, and to cancel hours I need to put that part on top. So even though they're not right next to each other, the hour on top and the hour on bottom still can be canceled out. So that leaves us with meters over minutes as the only units not marked. So that leaves us, if we do the math in our calculator, at 1,743 meters per minute. So, given that a lot of us missed this first part, this was an opportunity for you to hear the lecture that was done during class. And if you were here, this is an opportunity for you to get a little refresher uninterrupted. You have 2 options to finish the practice, both continuing in the paper copy and working on the online digital simulation. We don't have a lot of time to practice this style of it, but we will be reinforcing it as we move into the mold. Please see me or sign up for Flex if you have more questions.